Good morning, everybody. I'm not sure whether I've had the chance to meet everybody. I don't usually come dressed like this to keynote presentations, but my journey to Riga has been memorable. I always like to go somewhere and have a story. So my story to get here took about 31 hours, about 3 missed connection flights. I got in about 1 o'clock yesterday morning, but my bag did not. So this is it. I had to borrow a jacket, so I'm going to hide behind the podium, so on camera I'll look a little bit smart, but I am probably not dressed for the occasion, but hopefully the content is still memorable, so please bear with me. It's been a long journey to get here. And I also just found out that I'm much younger than Philip. It's only taken me 44 years to get here, not 45. So. All right, so let's get started. The theme of the conference is creating the world that you want to see. And really, there's 3 words in that you should think about. There's the creating, there's the you, and the world. Because these 3 words really are all about intention. It's about taking responsibility, and it's really a call to action to all of you, everyone in this room, to have some sort of sense of purpose. And when we think about this, just take a moment, right, and think to yourselves, what kind of world do you want to see? Right, just take a second. Because what words come to your mind? You just saw an amazing Slido. Maybe we could have done a Slido on this. It would have been great. But what kind of world do you want to see? Right, when we ask this question, we usually get some pretty common results. It's around, well, really, we want to see a sustainable world. Right? Maybe it's about being more resilient. We're having a lot more natural disasters around the world these days. Safety is a really key priority. Right? Or maybe it's this notion of a balance between this built and the natural world. And I think we can all agree that the world that we're living in today, it's really complex, right? And a lot of the things we're trying to solve are things that we've seen before. But there's a lot of new stuff as well, and it's evolving. And it's about this interconnected system. And it's humans, like you and me, it doesn't matter how you're dressed, right? We all have a major role to play. But if we think about the world, how it's changing, and how it's evolving, and how it's being challenged, right? We are, in a lot of ways, in uncharted territory here. And what's more, this uncharted territory of these natural disasters and the changes that are happening, they're happening faster and of more ferocity than ever before. But there are many different opinions on the cause of a lot of these challenges. Some say it could be the overpopulation. Others say it's the consequence of industrialization or commercialization, which have induced some of these things like climate change, which includes extreme weather, heat, water crisis, and ecological instability. But perhaps another way to think about it is that we, as humans, have simply just been living recklessly. We've been living above our means. And if you look at all the indicators, this simply just is not sustainable. Let's look at a bit of an example on this and the impact of us as humans. Now, these maps, they're beautiful. They show the greenhouse gas emissions in red and the carbon sinks in green. Now, think of these really as the lungs of the planet, right? As it spins around, you can start to see these giant red spikes coming out. Right? These are the greenhouse gas emissions, and the whole areas are red, where we are now carbon positive. Now, I find it intriguing to view these sort of data sets like this. Right? Can you imagine trying to visualize and understand this using Excel spreadsheets? Right? It would just be impossible. Putting all this data on a map gives it the context. Right? It allows you to see things in new ways, understand patterns that is meaningful, and it's being put in spatial context. And in this instance, I think it really is quite impactful. It is clear that we have been living out of balance with nature, which is threatening all of our futures. Now, I didn't want to start the conference with it all being doom and gloom and the whole world's coming to, an end, but it's really sobering to think about, isn't it? Because right now, we are actually afforded the luxury that we still have a choice. And I believe that you will all have a significant role to play if we are going to stand up and create this sustainable future. We have to take a collective responsibility, one and all, for imagining, designing, and creating the solutions and implementing them everywhere. Because really, what it's about is we need to start thinking differently. We need to embrace a lot of the new technology that we have, and we need to act faster, right? We need to move quickly, and we really need to act now. Because when we think about sustainability, in many ways, it starts with geography. Seeing the world as this one single ecosystem is where it all begins. And geography provides the science and the fundamental language to bring this all together. It is the ultimate integrator of the economic, the environmental, and social factors. It helps us to see these patterns and recognize relationships to develop a better understanding. We call this the geographic approach. It may be something you've heard Esri being used over the last couple of years. So geography and this geographic approach provide us this powerful new way of thinking. Right? I hope that's making some sense, because it's a way of problem solving. It's a way of bringing all this different information together, and it's about really approaching problems and solving them holistically, considering all the different relevant factors, which really is, as I said, what we need to be doing now. This is a diagram I'm sure you're familiar with. It's been something that we've used for a long time, but I think it really does articulate the core framework of what the geographic approach is. It provides a powerful platform for creating, understanding, exploring, and designing solutions, and then explaining them to others in a way that they can take action. Now, I'm not as new to GIS, I'm not as experienced in GIS as probably a lot of you in the room. I've really only been playing in the GIS field for about 10 years now. But in this 10 years, really in the last 5 years, I really am amazed at how fast GIS as a technology has evolved. It is advancing so rapidly, and the capabilities of how we can start solving some of these challenges is truly remarkable. It's bringing together really all your 2D, your 3D data. It's integrating in with GeoAI and advanced analytics. It's integrating now with your imagery and real-time data. And it's making all this information available and widely used across your organizations, both at the desktop, web, and mobile. It's a platform now for designing. And all of this really is now important because it is expanding your capabilities, your ability to see new things, and your ability to take action. So let's go a little bit deeper. GIS apps are now becoming more pervasive. What does that mean? Well, these apps are now connecting your organizations. It's connecting your operations team to the field. It's connecting the emergency response to the executives. It's enabling better citizen engagement. It is allowing your GIS data to be used right across your entire organization, your enterprise, and to external stakeholders. And this is happening now both in your mobile environments, it's happening at your desktop, and on the web. It is opening access to GIS, and it's expanding the reach and going deeper and broader within your organizations. One of the key things here that I like is how GIS portals are becoming more essential within these organizations. They're becoming key. They're enabling the way that you can both make your content available and leverage some of these capabilities. Portals allow the organizations to make all this content. It's connecting teams, it's connecting departments with other organizations, and it's allowing this dynamic integration and sharing of information. The concept of a portal to portal sharing is really about supporting multiple communities and different initiatives. But perhaps the biggest shift in the technology has come recently is this move on how your work is becoming interconnected. It's this notion that GIS is becoming distributed and connected. In addition to the more traditional deployments of GIS for projects being at the project level or maybe just at the systems level, we see this new pattern, and we call it the geospatial infrastructure, where many distributed servers now are being brought together. It is a system of systems approach. Every one of these blue circles in that area of the creating geospatial infrastructure, think of it as another portal. It's a way of connecting your organizations with other organizations. And this is a really transformational architecture which we will discuss later today. We'll have some great demonstrations on this, but it's opening up so many new opportunities for discovery and work among these organizations. Let's look at an example here about how this is coming together. This is some examples from the US. We see here, on the first one is the UN. The UN is using this distributed platform to bring together the information for the Sustainability Development Goals, reporting, accounting for these indices of the entire planet. The USGS is using it for doing conservation planning for 30 by 30 goals, identifying the highest value of these areas to put into permanent open space. And the International Geodesign Consortium is collaborating with about 200 different universities, and they're really starting to bring together the information sets to do climate mapping and resiliency. Now, this is very ambitious, and let's be honest, it's not something that you could have done a few years ago. The technologies didn't support this, but it is coming to life now, and we're seeing some great value along these lines of work of this distributed GIS model. I want to shift gears now. I've talked about some of the capabilities and key concepts of GIS and why it's essential and how it's advancing. But now I want to go a little bit deeper into some of our products and capabilities of what a modern enterprise GIS is. Because a modern enterprise GIS is much more than just your desktop mapping solution. It is composed of many products and capabilities, from Platform as a Service or PaaS, Enterprise, ArcGIS Pro, to the many other supporting applications that we have, which have been created to help and transform your organizations. I'm going to start by talking about ArcGIS Pro. This is really the corner or the anchor product that we have, which is our professional desktop solution, and really we have millions of users using Pro now. Now, ArcGIS Pro features major advancements in its cartographic visualizations, the editing, the data management capabilities, and the now built-in analytical capabilities. Now, ArcGIS Pro provides a rich set of data, which is engineering tools to bring together all the different important data sets that you have for GIS professionals to get their work done. It also is tightly coupled in with our online and enterprise solutions, which we'll discuss soon as we work through this presentation. But we also have now ArcGIS Pro extensions, which also add focused capabilities, such as your analytics, your map productions, your data management. All of these are created to support your work, and we'll see these applications in a few of the demonstrations. When we look at ArcGIS Enterprise, this is a GIS infrastructure for your organization. It supports the data management. It supports the mapping and visualization. It's your content discovery. It's your spatial analytics. It's how you do your sharing and collaboration. Now, we've made a number of advancements in these areas in the past year, and you can see a list on the right-hand side of the screen here. Now, ArcGIS Enterprise supports on-premise and cloud deployments. We support Windows and Linux, and for organizations with requirements where you need massively scalable cloud-native deployments, we also have now added Kubernetes. Now, Kubernetes makes scaling and managing your ArcGIS Enterprise deployments much, much, much easier. If we look at ArcGIS Online, now ArcGIS Online is our SaaS, or software as a service environment. We continue to see significant growth in the deployments of both online and our new users. Now, I came from a utility in Australia, and I've worked with many utilities now around the world. And I only have to go back probably 3 to 5 years, and these utilities would tell me, there is no way we're ever going to move our data to the cloud. That'll never happen. Fast forward now to 3 to 5 years later, these guys are a cloud-first deployment model, and everything is moving to the cloud. There has been a massive shift in how organizations are moving to the cloud. So a few examples of our improvements in the past year in this space include spatial analysis tools, which are being added to the map viewer, which allows you to quantify patterns and better understand the relationships of your data. We're improving all of the administrations, so now administrators can create reports that help them see the trends in the traffic to specific items in their organization. And we also added a new app in ArcGIS Online called Data Pipelines. These allow you to simply transform one data source to another into features. Now, if we think about ArcGIS as an enterprise system, what does this mean? Now, ArcGIS is a system with all of its toolings and platforms, and we offer it across the entire organization. It is holistic, it is interconnected, and enables you to build and run and maintain digital twins of your site, your region, your state, or your country. ArcGIS also integrates all the different types of data. You can see many different types of data sets on the screen here. Think of your GIS or location as being the ultimate integrator. It doesn't matter whether it's a spreadsheet or it's a tabular data set, whether it's imagery, voxels, or graph engine databases. Everything is connected through location. Think about everybody in the room here today. You got up and you shook the hands with the person next to you. You didn't know anything about them. Do you have a relationship with that person? Or you do today? Everybody is in this room at this point in time. The thing that is connecting you right now is location. Everything in your databases, within your organization, almost everything has a spatial component. You can connect data sets. You don't need to have a unique identifier. You don't need to have an index created. Everything is connected through location. So when you think about your data set, your data models, your information models, think of location as being that ultimate integrator. And then when you think like this, you can then extend this. So what does GIS do that is so powerful? Well, it does. It uniquely connects all these different data types, but it then makes them readily available, which is unlocking many other additional capabilities. Things like imagery, remote sensing, field operations, 3D, GeoAI, and many more. So ArcGIS and the geospatial infrastructure, it really is this foundational GIS that works with your data, unlocking value across your enterprise. So when we think about enterprise within your organization, it probably looks something like this. The GIS used to be just your mapping system off to the side. You may have had a deployment model where your GIS could go down for 3 days and the business would still run fine. The GIS is being moved away from just being a solution that was off to the side. It is becoming mission critical. It is integrated into your other enterprise systems. It is a node in your enterprise system network. It bridges that gap between OT and IT. It connects your real-time data sources from things like your SCADA sets. It aggregates that information up. It brings in stuff from your asset manager system or your ERP. It connects in with your customer management, and then it serves that up across your entire enterprise. Nothing else within your environment can connect these different types of data sets and share them pervasively across your organization like a GIS can. So when you think about these transactions that are happening at a system of record, it goes far beyond that. You've got the system of record, which is tracking these transactions. So your GIS and other systems of record and the associated information and governance that goes with that. But then there is this system of insights. So the system of insights is your analytical and your visualizations. It helps you make better business decisions by utilizing things like your advanced spatial analytics and other technologies like 3D and AI. And then you also have this notion of a system of engagement, probably the most powerful capability within your GIS. This is the ability out of the box where you can control not just what users see, but you can control what they have access to, and then what they can do with that information as well. The system of engagement really is the way that we are creating and promoting a culture of sharing and collaboration, moving the work that you do from the back office into the hands of everyone within your organization, from the mobile workers to the subject matter experts to the executives in the boardroom, even out to external stakeholders or citizen engagement. ArcGIS now allows and enables people to work together by sharing data, apps, and the knowledge. Now, in the last couple of years, we've been moving very heavily into assisting and working with our customers on building the digital twin. I lead Esri's digital twin practice and messaging that we've been working on now for a number of years. And 3 years ago, Esri actually joined a consortium called the Digital Twin Consortium. Now, it's a group of organizations, about 300 companies, that have come together. And what we're doing is working to create best practices and standards about how we integrate technologies together. And a lot of our big friends are in there as well, like Microsoft and Autodesk. And our customers are really leaning on us hard to say, we need you to figure this out and help us. How do we get Autodesk and Esri working better together? How do we get Autodesk and Esri and Microsoft and SAP coming together? We need better interoperability. We need better interconnectivity between these systems. We want to move the technology forward. And there was this realization that no one company has a digital twin. Like, the model can't be that you go out and buy ArcGIS digital twin. A digital twin is almost like the carrot that sits in front of the donkey, and you're always walking towards it, but you're never going to get there. And in my opinion, the reason that is because the technology is moving faster than you can deliver on the capabilities right now. So think about that. If I was to ask everybody to give me a definition of a digital twin, I think I would probably get there, 600 people in the room, I'd probably get 200 different definitions. And the reason for that is that everyone has an idea about what they're trying to achieve, some sort of business outcome. Right? But the digital twin typically is built around what you had as the technology that was available at that time. And as soon as you get it, as soon as you deliver it, you realize the technology has moved now. And now I want that, and now I want that. So the successful digital twin is not about having one product, but it's about being a node in that network and connecting into everything else. And that's what your GIS can do for you within your digital twin platform. Think of it like this. ArcGIS connects many different information models. It's not just about connecting the systems. I'm talking about connecting different information models. So if you're working in the CAD space, you'd be very familiar with working with BIM, building information models. And we have great partners like Autodesk that excel in working with BIM. Right? Esri is not going to move into creating BIM models, but we consume that BIM model. We bring that in. We have environmental information models. That is something that Esri does very well. We have capabilities in the Living Atlas. All the data sets, the digital terrain modeling, digital elevation modeling, soil types, air quality, everything that is about the environment, we can bring in those models. Recently, we've really advanced our network information modeling with the release of the utility network. It's the ability to have connectivity of linear assets, right? Electric lines, power lines, water networks, rail, etc. And now we're looking at aggregating and scaling those different models at a city. What happens when we start connecting those in and abstracting that back at a city level? GIS is connecting all these different information models. It's not just about one model. It's actually about bringing all these different types of models together. And it looks like this when we start bringing it across a life cycle for a digital twin. It's about how we capture and integrate that information. Step one, if somebody comes to me and starts wanting to work on a digital twin project, it begins with how you capture and integrate your data. My first digital twin project was a project in Australia where we had to fly the entire network of our power lines. Took about 12 to 18 months to deliver this project. Now, that was to capture the data, process the data, and turn it around into analytics. The project was created because we're doing vegetation management. So think about that. We had this beautiful 3D digital twin 18 months after we started it. But the purpose of it was actually to monitor vegetation growth. So by the time we got the analytics back, the trees that were bad were now very bad. The trees that were going to be bad are now bad. And so although it was a digital twin, it was a stale digital twin of 18 months ago. Technology has shifted now. You have to integrate it, you have to maintain it, and it's got to remain current. So then we move on to the next phase, which is the real-time visualizations. Being able to visualize these things in 2D or 3D. And then we want to move into now, not just what it looks like today, we want to do the analysis and predictions. Then we move on to sharing and collaboration. This is that system of engagement, taking all this data and moving across your organization. So this is where our messaging had moved to over the last 2 years. But this year, we moved forward again and started to help our customers. Well, there's different really levels or maturity of a digital twin. And some of our customers are more than happy just to get to the descriptive level, the level at the bottom there. This is capturing the data, reality, and it's creating what we call a static or a virtual model. Right? This might just be a visualization of your plant or your facility. But as we start moving up this maturity curve, we start adding more technology, more GIS technology. We start adding in and connecting into IoT sensors. We start bringing in more of the advanced analytics capabilities. What we're moving to now is away from being a static digital twin and moving into what we call more a dynamic digital twin, where now we're getting feedback, we're starting to connect. Next, we move into predictive. Now, when we start taking these data sets and start looking at things like forecasting and simulation, start asking the questions, what if? What if this happens? What's it going to look like in 3 years, 5 years, or even tomorrow? The comprehensive GIS really is about taking those simulations or those outcomes and making the recommendations. So now all of a sudden it is learning and it is making recommendations on our behalf. The final stage really is autonomous. I haven't seen anybody get here yet, but it's that really now removing the human element completely of your digital twin, trusting everything. So this is where we start seeing a lot of these AI assists and decisions coming in. This is really what we consider to be an adaptive digital twin. Self-learning, self-healing, making decisions. Another way we've been thinking about how we deploy digital twins is it's very difficult when we see RFPs in the GIS space. I've seen many RFPs come out over the years and they say, we want a digital twin. And you say, well, why? I don't know, I just want a digital twin, right? It's a buzzword, people want it, but there's a reality, as I was talking about before. There is different technologies and different capabilities in different verticals when we think about digital twins. So you might be thinking, I'm on the environmental side of my organization. Your digital twin really might just be, I just need to create an environmental twin. I need the data sets for the environment, I need the technology to do that, but I don't really need to do all this other stuff. It can just be in 2D, it doesn't need to be 3D. You might work at a power company or a water utility company, and you want to do a network twin, and this is where a lot of people are right now. They're wanting to digitize their entire network, have connectivity, understand it, integrate it in with their planning tools. Next, you might do BIM and GIS. This is the design and construction twin. Then the planning twin, which is starting to do the forecasting, what if scenarios. Or we might be connecting in with your real-time sensors and in the control rooms and looking at the operations twin. These are all different types of twins with different capabilities and different technology. You don't have to do everything at once. You can verticalize your ArcGIS digital twins and start thinking about, well, what do I need to deliver today? And then maybe think about, after this, what do I do next? Because these are different lines of business often within your organization, and you don't have to disrupt everyone at the same time. Underpinning all this is reality mapping and data integration. When we think about reality mapping and data integration, it's really about we're connecting now all that different reality mapping information sets, those digital terrain models, digital elevation models. It's bringing in the data management that goes with that. So this is all the orthomosaics, information sets that go with them. And then finally, the outputs. So this is where we start seeing the object detection, the 3D meshes, the change detection, starting to use all these data sets and use them in your decision-making frameworks. And with that, I'd like to welcome to the stage to talk about the 3D digital twin and how you can make it live. Please welcome Davidas.
Thank you, Matt. So yes, hello everyone. My name is Davidas, and today I'm going to present to you a 3D living and interactive digital twin of a city. So what we have here now is a photorealistic 3D skin of a city, which helps me to see how the city looks now, but it is also a perfect contextual information for visualizing other GIS features, such as these 2D polygons. These polygons are overlaid over the 3D features, which enhances the visualization of this data and allows me additional capabilities, such as identifying these features, such as this building right here. And this is basically the data which shows energy consumption of these buildings. So here I can see the energy consumption of this building during the heating months, and I can see its factual energy consumption class according to this chart. While being here, I can also start analyzing a new building proposal. So this is a BIM file imported into 3D ArcGIS web scene. When we have this type of data, we can start exploring it using these tools. I can select a particular floor that I'm interested in. I can also toggle on and off some of these layers, and for example, see how the top floor of this particular building is going to look like. After that, it's also important to see if this building is in line with the legal regulations. So we can add dimensions. And these dimensions can help us determine, are we leaving enough space for the road here, right? We can also see, do we have the minimal required distance between the neighboring house, as well as check if our building height is also in line with the surrounding buildings. Of course, when thinking about building new infrastructure, we also have to consider existing infrastructure, such as these utilities. And typically, we are used to managing utilities in a 2D, but ArcGIS can help us to convert this 2D data into 3D. So let's see how this looks like. So here I'm using a slice tool to see that underneath. And immediately I can get more insight from this data by looking at it in a 3D way. So I can see how deep these utilities are located beneath the ground. I can also immediately see how they are crossing each other, how they are interconnected, as well as I'm able to see a clash right here. So for example, if this building were to be built, I see that this pipe will have to be removed or relocated. I can also identify features here, such as this manhole right here. I can see its properties, and I can maybe consider or design new connections from this building to this manhole right here. Another analysis that I can do is line of sight analysis. And this can be useful for developers for determining the price of the apartment depending on what the future residents are going to be able to see out of their window. So here I have configured 4 different line of sights to 4 of the more famous objects around Vilnius. So there we can see the bell tower of the cathedral, the Gediminas castle, the Hill of Three Crosses, and the Bernardine Church. So as you can see from this analysis, the future residents of this apartment are going to have a pretty good view. Let's zoom into a Bernardine Church. And this is a 16th century church, which is a great example of Vilnius Gothic architecture. And I can bring it to life to even higher detail by processing higher resolution imagery thanks to ArcGIS Reality. And I can provide this amazing photorealistic details for users. Next thing, I would like to take you to a different location where I would like to show you some interactive capabilities of this digital twin. So my task here is to find a suitable location for a school in this rapidly changing and developing area around Vilnius. So this location has been chosen for a future school. So I will use interactive tools to free up some space and flatten this gas station. I can do it easily just by a few clicks. I will draw a polygon around this area. And as you soon will be able to see, this gas station is now flattened, and I can import my school model and start analyzing it and seeing how it fits in this real context. Now I would like to take you to a Vilnius airport, where I would like to show you a capability where we can integrate IoT sensors, real-time data. So right now, you will be able to see that this plane is about to preparing for a takeoff, is approaching runway, and another plane should be soon coming for a landing operation right here. So let's just give it a moment, and we will be able to see that. So yes, you can see approaching a plane right here for landing. I can enhance the scene by adding a no-fly zones around the Vilnius airport. And these are strictly regulated zones for ensuring security for airport operations. And this is especially important for civilian drone usage. So for example, right here, we will be able to see a drone which is currently in a zone which he is allowed to be in. But as we know, drones have to be strictly regulated in terms where there can be and there cannot be. So once this drone will leave the allowed location, I will immediately be able to see that this drone is not allowed to be in this particular location, and then I will be able to proceed with notifying the local government or contacting the drone operator from the drone registry information about this incident and instruct him to leave, or some consequences will be applied. So as you can see, real-time integration example. And lastly, I would like to come back to the citywide view, where I would like to show you the future of Vilnius city. So right here in these 3D, green 3D buildings are showing the future developments of the Vilnius city. And do you remember that first building that I've showed you? It's also here, somewhere downtown. This yellow arrow is showing the location. And lastly, I would like to enhance the exploration capability of the scene by creating a 360-degree VR experience. And by creating this experience, I am allowing users to use it in a real location by using their mobile phones and interactively seeing how the skyline of Vilnius city is going to change once these developments are going to be completed. They will be able to identify features, see more information about these new developments. So, digital twins is the future of geospatial data management, and as you have just seen now, ArcGIS have all the necessary tools and capabilities for us to use in creating these 3D digital twins of cities or even countries. Thank you.
Thanks, Davidas. So as I mentioned before, that wasn't just one technology that you just saw there. How many was that, Davidas? I counted scene, 3D scene, I saw GeoEvent, I saw Pro, I saw, what else was in that? BIM data integration with the connectors. So you are now connecting multiple different tools together to create those digital twins. And this is the concept as we start building this. You also saw ArcGIS Reality, which was doing the overlay of all the photogrammetry information sets over the top. So that was a great example about how we create the digital twin and make it live and start connecting some of our tools to help you solve some of those problems. That was a brand new build, that was a build on an existing site, and then it was some urban planning and then some real-time integration with that example of the plane coming in. So I talked about the environmental twin. So what does that mean? So there's a couple of key components here. The first is understanding all the different data sets that are readily available to you to better understand your environment. So this is things like your elevation, your soil types, your vegetation, your weather, your air quality, your biodiversity information sets. But then it's also about what you want to do with this information and how you want to do some analytics. So bringing together your climate trends. We had some examples before from the USDA. So we're talking now extreme heats, it's the wildfires, it's the drought, it's flooding, storm surges. All these different information sets are all connected to help you better understand your environmental twin. So you need this information as almost as a foundation before you start moving on to some of these other elements, such as your planning twins or your design and construction twins. The next twin I want to talk about is your network twin. Now, I touched on this when I was referring about the information model for your network information model. Now, for many utilities, they're realizing that the grids that they have today are not going to meet the needs of the grid of the future. They're going under significant change right now. And so Esri has worked very hard over the last decade to create a new and advanced data model, which is helping them to manage and model what this future grid will be. And there's really three main components. It's about the advanced network modeling. Now, this is about the connectivity. So everything is managed and connected within those networks, whether it's electric, water, district energy, telecommunications. It's about also modeling the complex network with their assets. It's about the data visualizations. It's about the understanding all the 3D components that are now enabled throughout this technology. It's creating these things like schematics and diagrams. Then we move on to the visualization and analytics component of this for the network model. So this is where a lot of the value comes through, and this is where you can do things like you just saw before. Connecting the 3D and the BIM, you can now go above and below the ground. A lot of these assets are hundreds and hundreds of assets at a single point on a map. You need to understand these now and look at almost the internal layouts and see them in spatial context. Now you can actually go and actually understand what these building and plants and structures look like. And then, as we touched on before, because it's services-based architecture, this is now enabling that sharing and collaboration of this information across your whole enterprise. You can take what you used to do as a heavy desktop user and now move that out to the field. What does that mean? Well, if all the business rules and network logic, which are inherent in your information model for a network, are now available to the person out in the field, when they go out to do a data edit or a data change, the same rules that apply at the desktop are now being applied on the mobile device. So people going out there cannot pull bad data back into your system. They cannot create bad information. Everything is validated and follows the same rules as if you were a designer at the desktop. This streamlines so much of your data collection and reduces a lot of that information latency of your as-built processes, moving it from that legacy concept of being anything up from 3 months to 2 years before that data comes back. And now you can take this information and get it back in real time. To talk about how we're integrating live data into the utility network digital twin, please welcome to the stage, Donatas.
Yeah. Thank you, thank you. We all have clean water at home, and just think about it. Isn't it a luxury, by the way? So for all this to happen, the water distribution company needs to have a lot of information, all the details, every bit of information about everything in the network. So you can see here ArcGIS utility network. It is a collection of information about all the different devices, pipes, and so on, which exist in the water distribution network. And it's not only a map, but it's also, it could be visualized not only on a map, but also in a schematical way, or analyzed, updated. The data could be collected daily and so on. So for example, here I am going to show you where this sub-branch of the network is just by simply clicking one single button. So let's move from this to something even more amazing. I am going to turn this into a real-time system. To do that, I have a GeoEvent-based service, which is getting the data from SCADA devices about water flow and pressure, and then it reacts to certain situations which may arise in our network. So here in our network, I have multiple meters which I am monitoring, and now I am following one single meter. So as you can see, this diagram shows water flow and water pressure. The ratio between these two it could actually potentially show us as a location of incident. So what just has happened, it's an incident, probably a water leak. As you can see, the water flow went up and the pressure went down. So the system automatically generated an incident location and also reported this to me through an email message. Now it starts to automatically look for a solution, and now as I was talking to you, it found it. So I may open my automatic actions plan. So this is a story map which was created automatically by the job processing service, which did several tracing operations against my network. And we can look at this now. Here is our incident location. Here is the valve which needs to be closed to isolate this location. And here we have 4 users of this network which are going to lose the connectivity. So maybe there is a possible loop through which we could feed water through another pipe. So it also found us a possible loop, and then it found a possible a valve which needs to be opened to basically get this water flowing from another side of this loop. And now, finally, we could isolate our incident just by closing 2 valves, and one single user is going to be left without water. Now I'm going back to my dashboard, and I can also simply click Apply Proposed Changes. So that is, I am basically changing the status of those valves. This valve is now opened. These 2 valves are closed. You can see it's by color. And my meters will start to respond that the flow is going down, the pressure is going down, there is no water leaking through that location. As you can see, it's a self-healing network. And thank you. I will enjoy my water, and back to you, Matt.
Thanks, Donatus. So once again, we're looking at the technology being used and bridging together. So you were connecting the utility network in with their real-time SCADA feeds. They were then running geo-event processing to determine what needs to happen to rectify that and using the traces that exist. It started off with a view between ArcGIS Pro on the left-hand side and seeing some of the operational schematic views. Those two views are interactable. So if they're used to working in this schematic view, you can select what do you see on the right-hand side, you'll see it interact on the left-hand side. This is the first time I've seen an example of some of this coming in and doing that self-healing network. So if you think back to those different maturity levels of a digital twin, when we start saying we're starting to trust the technology completely, not really. We actually had that final step in there that said, I am going to still click that button to turn the, I'm checking what it's recommended, and then I'm making the adjustment to say, yes, I will authorize that change and close those two valves and restore as much of the network as we can. But all the decision making about what was an upstream or downstream device was all calculated and responded back and helped us make that decision. So this is making those organizations move through that maturity curve. And we managed to get all the way to the second top level there, all still working in 2D. It does not have to be completely in 3D. So we move along to the next type of twin that we have. We call this the planning twin. And there's a number of different capabilities, and we saw some of these in the first presentation. So when we think about the planning twin, this is where we start understanding digital planning. It's about the ability for us to understand regulations and policies and zonings. It's about land use. It's about how do we actually help understand what is going to be built and where. Then we move into the design phase. So we move from maybe working in an ArcGIS urban into working into our city engine capabilities. And we saw some of that in the first presentation when we moved into the augmented reality view. This is where we start seeing those realistic 3D visualizations. It's about looking at 3D designs in context, the building facades, the streetscapes. You start bringing these designs to life. And then we can now move into what we call the engage stage of the planning twin. So this is where we start seeing how we can now move into some of our advanced capabilities. It's about the transparency and collaboration. It's about sharing with public engagements. But it's also about potentially integrating in with some of our other capabilities or utilizing some of our SDKs with our game engine technologies, creating these true simulations of what it will look like in the real world. The next twin I want to talk about is the design and construction twin. And we have touched a little bit on this, but a lot of the work that we've been doing in this space has been one of our strategic partners, Autodesk. So Esri and Autodesk have been working fairly tightly for the last couple of years, and we've started to develop some products which are designed to help streamline a lot of your building, design, build, and management lifecycle. One of those technologies is actually GeoBIM. So it's created in a way that we're connecting the Autodesk Construction Cloud with Esri's technologies. So this is really helping streamline a lot of your project delivery workflows. It will allow your BIM manager and construction manager to view BIM projects within its 3D context, right? So it also then gives you access to a lot of the other information sets that exist in Autodesk, like all the documentations. And you don't need to switch between the applications. You can see both of these things running side by side in the same viewer. Now, to talk about how we can put design into context using GeoBIM, please welcome back Dividas.
Thank you. Thank you, Matt. Okay, as Matt has just introduced you, I'm going to present ArcGIS GeoBIM solution, which links BIM projects and workflows by interconnecting GIS and Autodesk Construction Cloud. Now, building a sustainable infrastructure is a difficult process because critical data supporting such developments are more often than not stored across multiple systems, making information difficult to access for decision makers. And this is where GeoBIM comes in and helps us with that. So what you're seeing here is a BIM model of a proposed new pedestrian bridge in Vilnius. And this file is located in Autodesk Construction Cloud. This is where BIM project managers, design team is working, constantly updating their files and storing their information here. Now, we know that BIM and GIS is two separate, distinct worlds, and GeoBIM combines them into single application. So let's see how it looks. So right here, I have a 2D map with 3 ongoing projects in Vilnius area. So let's zoom to one of them. So right here is a Vingis pedestrian bridge project area. I can switch 2D map to 3D map, and here these orange polygons are actually displaying a geographical boundaries of different IFC files that are located in the Autodesk Construction Cloud. I can switch geographic boundaries to a actual full plan of the proposal. So right here we can visually see the scope of this project, what is going to be done here, new constructions, but I can take it a step further and import all the 3D information here. So let's see how it looks. So now I can clearly see how this new project is going to look like, and I can visually start analyzing it and using some different tools. One of these tools is that ArcGIS GeoBIM can provide us with dynamic linking capability. So this capability allows us to select any of the object from this project, and immediately I can pull up an original BIM design file from the Autodesk Construction Cloud in a single app. So as soon as it loads, you will see that I'm immediately zoomed in to this particular exterior lighting post, and I'm able to explore this view, this original BIM file, and see all the details of this exterior lighting design plan. I can see all the interconnections, I can see different wires, I can select them, I can see their attributes, and generally explore it. So what we are seeing here now is single application with two views, GIS and BIM. So this helps us to interconnect and act upon the data from these different sources. But generally, and GIS is used in early phases of developments like this, when we are trying to determine how developments like this are going to be affected by natural and built-up surroundings. So for answering these questions, we can use GIS data. So let's zoom a little bit, and let's add some additional data for us to evaluate. So first of all, I will add city zoning plans. So these plans are showing me some of the areas of the city which are specifically left for some developments, or for example, for some parks. So this green polygon is actually showing the area which is reserved for natural surfaces, greenery, and parks. On the other hand, we see these brown and orange polygons which are reserved for developments. We can also add another layer with future residential developments in this area. And we can see that there's going to be a lot of new development in the future. We can also add pedestrian infrastructure and biking paths around this area, and now we can clearly see that this park has a great pedestrian infrastructure, but what also becomes apparent that the residents in the south side of the river do not have a direct access to the park. So by building this bridge right here, we will increase the living standards of the residents by providing them a direct access to the park. We also possibly reduce car traffic by promoting a sustainable way of transportation, such as walking and biking. And I would like to thank Vilnius Planas for providing me all this data for you to show. I would like to then come back to the design itself and maybe see how it holds up against the spring floods, which are very common in the river Neris right here. So I can easily simulate this by adding a layer with increased water level. And then I can start analyzing this design. So by taking a closer look, I can immediately see that this sidewalk is at risk of being flooded. And I can also turn on an issue layer, and I can see all the issues assigned with this project. And I see that the issue about this is already have been created. So I see that this is a requirement change for designers to change or update the material so that the water would not do a long-term harm to it. By exploring this design with increased water level, I see another issue here. I see that not only a sidewalk can be submerged, but also a manhole right here. So I will notify BIM designers about this. So I will create a new issue right here. I will select a location on a map. I will provide a type, issue title. I will link to a specific document, so this is already have been selected for me. I will provide a root cause, and I can optionally provide description. Once this issue is created, it is immediately synchronized with Autodesk Construction Cloud so that the BIM project team can act upon it. And finally, I would like to show you my issue dashboard. So this is the dashboard which shows all the information about the issues which are assigned to this project. And this dashboard is really useful for GIS specialists, for BIM project managers and executives to see how their project is developing. So we can see necessary information in graphs and charts. We can also see the issues on the map, and I can even select them by different categories and understand better why are these issues occurring here. So as we have just seen, GeoBIM can be a foundation for your BIM workflows. It will ease up the process of bringing your BIM files into geographical context and enable BIM design teams and GIS specialists better collaboration. Thank you.
Thanks, David. That's brilliant. One of the biggest problems that the AEC has in that design and construction is that every phase of a project, there's information that gets lost as it transitions from one person to the next, or as it moves from one phase of the project. What we just saw there is how you can manage the entire design, keep track of issues, keep everything aligned, and everybody is working from the same information set. So it really helps you stay aligned and manage your projects more effectively. It's a great example. Moving along to the operations twin. Now, this is one of the twins that I think has got one of the biggest impacts. We saw some of the dashboards just now on both of those demonstrations. We're bringing together a lot of information sets and representing them in the dashboard. And that's often used for managing inside the control room or that operational view. It provides that common situation awareness view of what is happening on your network or your projects or anything else in your organization. But what we're also seeing is this relationship of operations twins connecting what you see in the control room or on those operational dashboards with what is actually happening out in the field. We need to connect the operations twin of the control room to the people out in the field. Too often we see that field crews are going out and working on data sets that are 3 months old. The GIS data set was the normal state of the network, or it was legacy information. It really does start to impact your organizational safety and the ability to respond to events quickly and efficiently when your data sets are out of date. So having that operations twin that is taking that real-time data feed and moving it from the control center to the end user out in the field has become more and more critical for a lot of organizations. We've seen a lot of the technology just now in the first session. And we started the session starting to think about what sort of world did you want to see? And hopefully, as we step through some of the technology and some of these capabilities, you've started to appreciate the role that GIS has in creating a sustainable world. But hopefully, you've also started to reflect and think that each of you has a really important and unique role to play as well. And you know how to determine what's needed and what is wanted. You understand how to bring it all together. You're the ones that are trying to solve a lot of your issues within your organizations. You need to create these holistics. So to conclude, I'd just like to say that creating the world that you want to see is going to require GIS and this notion of this geographic approach. But most importantly, it's going to require you. It's going to require you to start thinking differently. It's going to require you to start thinking spatially first and leverage the power of a modern enterprise GIS and the digital twins of our future. And with that, I'd like to hand it back to Javila. Thank you very much.
Matt, Donatas, Dovydas, thank you so much for such an in-depth presentation and overview. And I'm aware that we're going to go into part 2 after the coffee break, right?
More to come.
Great. So we have half an hour for the coffee break, where you also have some booths where you can ask questions, meet our sponsors of the conference, and of course to discuss how can we make this world a better place. See you at 12 o'clock sharp.
Nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction.
Inches of rain this morning. The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.
Back everyone after the coffee break. So as we can see from our expectations board, I guess the coffee expectation was met. Yes, no? Everyone had your cup of coffee, tea or water? Amazing, very good. And right now, what else we can see? The top winning expectations for this conference and for the day was knowledge, new ideas, inspiration, new knowledge, connections. So we're still going to have a lot of time to connect to each other, and right now we're going to dive deeper again into the technology with ArcGIS, and we're going to continue with part 2. We already have our whole team here on stage. We can say hi. They're going to do us again some great demos. For everyone who are joining us after the coffee break, we still have some seats here in the front. Don't be shy, come here, because I promise you it's going to be interesting, in-depth and interactive. To continue the part 2, I would like to invite Matt back on stage. I think he has also some great news. I heard your luggage got back.
Thanks, Javilla. Starting to feel like a Taylor Swift concert. I just had to have an outfit change between acts. Luggage did arrive. I feel much better now. Can we start again? We'll do Act 1 and then we'll... All right, the crowd's pretty full in here. It must be the big panel of experts we've got doing the demonstrations for the next session. So thank you for coming back. Really do appreciate. I hope you enjoyed your break. I did see that lunch was also on the Slido, so this session is between you and lunch, so we'll make sure we stay on time and get you to lunch. The next session is really about technology updates. We covered off some of the high-level messaging, Esri's vision, and the capabilities, how it's applying into digital twins and smart cities and infrastructure in the first session. Now we're going to go a little bit deeper into some of our technologies, and we've got a great showcase and panel of experts to take you through these capabilities and really start to educate what's new with ArcGIS. We talked a little bit about ArcGIS being an enterprise system, but it really is also what we consider to be a comprehensive geospatial system. And what I mean by that is that it really supports multiple communities and enterprises, and it leverages all of this technology through the foundational products. And you can see them up here, such as Pro, Online Enterprise. And these ArcGIS products are all available as SaaS, PaaS software systems. So we talked a little bit about that in the first session. But as mentioned earlier, it also supports many different implementation patterns, and it's really adaptable to whatever your organization needs. I made a comment before about a lot of utilities now implementing cloud-first approaches, so they're starting to adopt a lot of our SaaS offerings. But that is not always the case. We still have a lot of clients which need to have all of their data on-prem for a number of reasons. So we can deploy any which way you'd like, whatever your organization needs. But it really is a common platform which is being used and shared that is scalable, reliable, secure, and it's really been designed now to be interoperable with other systems. And we talked a little bit about that in the first session on how we're integrating GIS with a lot of your other enterprise systems. ArcGIS is rapidly advancing, and you can see here that it really is continuing to advance. Phil mentioned that we put about 1/3 of our revenue back into R&D. That really does set us apart on how we are really accelerating the technology to meet your business needs. And these innovations are really integrating and leveraging and leading the science and technology to continue to serve your needs. And we'll continue to do that to make sure you're successful. ArcGIS is a content sharing and collaboration platform. So this makes our platform the leading platform to providing access to geographic content to everyone. So over the last few years, Esri and our users have shared tens of millions of maps, data sets, and apps, and made them open and available for everybody else to use. And this is creating the world's largest digital map library. It really is quite exciting. Did I go one too far then? Nope. Okay, so ArcGIS also includes the Living Atlas of the world. Who regularly accesses the Living Atlas of the world? Just a quick show of hands. Rightio, just as I thought. Probably one of the most underutilized capabilities that you have access to. So this is a community contributed data set, and it's the best commercial sources which are created by Esri. So we have thousands of layers of data, which have all of the demographics, your base maps, your imagery, and so much more that covers all across the Earth, right? The list on the right shows some of the new capabilities and global data that we've added in the last year. One example, which you should be taking advantage of if you're thinking about moving into 3D, is the 3D base map for the entire planet. This is all the buildings and the terrain and all the other 3D content. So this content is built from the best commercial and community sources, and it's made available to you as a GIS-ready content that you can just access and integrate into a lot of your own work. There is literally thousands and thousands of layers of data that you can start bringing in. If you're starting to try and understand social equity, starting to understand income, EV, purchasing, anything that's got any relationship to the Living Atlas, this is all made available to you, and it's available to bring into your analytics. ArcGIS is also a complete mapping and cartographic system. So it includes hundreds of tools and powerful capabilities like dynamic visualizations, smart interactive mapping, and it supports many different styles of mapping like dashboards and story maps. So I'm sure many of you have used dashboards and story maps. They're one of those low-code, no-code solutions that are easily configurable. Now these capabilities are advancing both the cartographic science and your map visualizations, which is helping us to improve how we communicate geography, which including things like instant apps, dashboards, story maps, and all of these, as I said, can be accessed without writing a single line of code, which for engineers like me, we definitely do appreciate. In the mapping and cartography, the new enhancements of our layouts and our symbology, the labeling and generalization in ArcGIS Pro are making it a lot easier for you to create beautiful maps. And you can see a lot of these new capabilities are listed on the right-hand side. When we think about interactive web mapping, we're seeing an increase in the use of web maps and using smart and data-driven visualization tools. For example, applying things like our layer effects to get amazing cartographic products, or looking at the data over time for aggregating features or creating new ways of sharing information with infographics. All of this is leveraging the power of the browser. Instant apps are templates that help you quickly transform web maps into web or mobile apps. So just think about that. You're taking your simple web maps that you've created, and now you can turn them into a web app or a mobile app that provides your audience now with intuitive experiences to interact with your maps and data. Now, we have currently deployed, I think, 18 different templates in Instant Apps, but we are delivering a lot more in the coming future. Now, to take you through some of the latest innovations in smart web mapping, please welcome Raminta.
Thank you. Okay, everyone can hear me. Great. Visualizing our data is important when we want to attract attention to specific information. Here you can see demographics data from Living Atlas that shows total population in nuts-free areas. As you might imagine, administrative units usually do not reflect the true concentration of population, so this map might not be as effective as I would want it to be. So for that, I will make few changes, not going into ArcGIS Pro, just to show you that you can achieve great cartographic results right here in your map viewer. So for that, I added another layer from Living Atlas that shows world population grids. And as you can see, it's much better image right now. But now I have all this data around that might distract our users, and I want them to focus only on the Baltics. So what I will do, I will add a blending mode, which will visually crop my data based on the polygons, administrative units underneath. So blending modes define how your layers are displayed in relation to one another. I think this looks much better, but I still feel like there is too much noise in the data, and I would like to eliminate areas where there are no residents. So for that, I will use another layer from Living Atlas that shows human population footprint. So these are the actual areas where people live. And I will add another blending mode called Destination In to also crop the data, but get the underlying symbology as well. And finally, I will add a simple blur effect to make this just to look a little bit more smooth. And as you can see, we can now clearly see how the population is distributed, how densely, and the clear differences between our three Baltic states. So as you can see, we do not need to go to ArcGIS Pro to create great visuals. Next, with the latest release of ArcGIS Online, it's becoming easier and easier to create more lively and unique maps with your own styles. Here you can see animated weather symbols, which were published from ArcGIS Pro and can be easily accessed through your web map. As you can see, the style is available for me to use. But creating great experiences does not end with great symbology. We also need labels and pop-ups. And for the labels, I used a little bit of Arcade, which is an expression language used across all ArcGIS platforms. And this allowed me to convert wind direction degrees to arrows that are more comprehensible for users to understand. But let's not stop here. Next to my points, I have a related table with weather forecasts that are updated every 3 hours using Power Automate from an open API, which is provided by Lithuanian Hydrometeorological Service. So with that, and a little help of Arcade, again, I can visualize my related data and get this nice-looking forecast. Next, you can see that I have some additional layers showing different aspects of weather in the Baltics, and you might know the struggle when you have to turn every top layer to get to the bottom one. Well, now you can turn exclusive visibility on your group layers that allows you to show only one layer at a time. And just to mention that this temperature layer underneath was created right here in your browser, using analysis tools and analyzing patterns. So again, no need to go to ArcGIS Pro. And since we come from different countries and English might not be our native language, you can now create instant apps with language switcher. So it's really easy to translate your application into multiple languages just by simply entering those translations in the app. And as you see the final result, here we have everything in English, and if I switch it up, for example, to Lithuanian, we can see that every text component is translated. But again, with the help of Arcade, we can even translate our data and our pop-ups. If I select an area in Lithuania, in Klaipėda, we can see, if you notice before it was in English, now we have it in Lithuanian. And if I switch it up to Estonian and probably select some area in Estonia, Let me just click on that. You can see that the pop-ups are translated again. So you can see that it's becoming easier to create sophisticated maps with high usability for your end users right here in your browser. You can go from idea to reality using ArcGIS Online and Map Viewer. Thank you.
Thanks, Ramenta. A great example about how quick and easy it is now. A lot of that stuff you had to be using the heavy Desktop Pro to do a lot of those configurations. Now it's just at your fingertips in the web app and pushing them into the web apps. So really, really well done. Thank you very much. I want to continue this thought about how we can help you tell stories. And a lot of what we do now is storytelling with maps. You saw that in the first session when we automatically created one of those story maps. And that was generating a way of communicating what was going on in that event. So as you start bringing in information sets with a map, it helps you provide context in what is happening. So telling stories through maps is a really powerful way of communication. It is used in presentations and in education, and we've made a lot of advances in this space as well. I'm going to draw your attention to two things that are on the screen. The first is a new kind of story map, which is called briefings. So this can be used for information to, as we do, the daily briefings to the White House every day to the president is actually done in a briefing story map or to an executive. So it's a great way of communication at a high level, bringing in the data sets. The other is a new e-magazine called Storyscape. So this is a monthly selection of a few story maps that celebrate stories and storytellers across a diverse global landscape. So if you haven't seen these two new types of story maps or the ability to tell these stories, I do encourage you to go and explore these. Once again, they're very simple, no-code solutions that you can configure and deploy within your organization. Another thing, advancing of our technologies is ArcGIS Hub. So ArcGIS Hub is really an easy-to-configure community engagement tool or platform that organizes the people, the data, your tools through information-driven initiatives. So organizations really of any size or any type. A lot of people think you need to be a big organization to deploy Hub. That's not the case. It's really any size organization. So it could be a government organization, non-profit, academia. You can really start to maximize how you engage and communicate and collaborate and share your data using ArcGIS Hub. And we recently improved how we can search, how you filter, how you can engage with projects, and upload a lot of the different data sets from your community, just to name a few. So to take you through how you can, the use of ArcGIS Hub for community engagement, please welcome Eva.
Thank you. Can we change the screen? Yes, that's the one. So ArcGIS Hub is a tool to easily use to create pages and to highlight your high-value data and engage with the community. Here we see a site in an edit mode, and it is an easy low-code, no-code environment. Just choose a layout element and drag and drop it to configure it. So for example, here I'm dragging in a gallery to display my applications. And just as easily, I can go back and select, for example, a map element to add an interactive map to my site. I'm pulling the data from my ArcGIS Online site, and just as simply, we have the interactive map added to our site. We can then publish it, and let's view the end result here. As you see, exactly the same view as we had in edit mode is in actual published mode. With addition, you can add text elements and provide key performance indexes to be extra transparent. With ArcGIS Hub Premium, you get options to publish events and also invite community members to sign in or sign up. This is also available for your partner organization if you don't want to have them in your own ArcGIS Online. So the sign up and sign in process allows you to use social logins or government-provided identities, which provide you extra high level of assurance. When I sign in with my ID card, I am transferred back, and we can see that members have additional information for them that was not available for public. For example, here we have an additional information with invitation to add our comments. So this is an extra new availability to participate in discussions. By opening up an item, we can see that here is an ongoing public consultation. Users already have added their comments, and we can see that they can add their comments and easily get replies. With that mentions, users will receive also an email to their inbox. So how do you add a comment? Let's look at these buildings in blue here, for example. Here we see one courtyard and another one, but here is one missing. We would like to inquire about this. By adding our comment, we can easily drop a pin into the place about which we are talking about and add it to the comment. So everybody who comes to this item will see exactly about which place we are talking about. Additionally, with private items such as these 2D maps, 3D maps, or even documents, we have public discussions. For public discussions, we can go see another site. Here we have a small Northern Estonian community page for Loksa town. They are currently in a progress of planning stage, and they are modernizing the city's town center. With the excitement the community has, town council can engage the people in the beautification project. A project is clearly defined goal, has a clearly defined goal, and in the early stages we can see that already community involvement can be had. By adding a discussion board, we can see that all the ideas are publicly available without even needing to be signed in. If you want to add a comment, you have to sign in. Let's use our member ID and quickly sign in. So, as it's loading, we will see that we can have predefined area, and only comments within this predefined area will be accepted. If we go outside, it will be not accepted. We can also see that there are different ways to view these comments. Here currently it is in map-centric view, but changing it up to the grid view, we can see all the comments in one place as such. Also keep in mind that you can add to one comment different size, kind of points, polygons, and lines. If you are worried that the public discussions may be derailed, then it's easy to hide comments that are not participating in a constructive manner. So whether it's facilitating public consultations or managing beautification projects or fostering collaboration, ArcGIS Hub provides an excellent way to connect with the community and make data accessible. Thank you.
Thanks, Eva. So as I was discussing it, like a great example there about how Hub can be used for a number of examples. He went through an example about how you access it, how you can control what access. He looked at it from internal view. So how do you, if you were just deploying Hub within your organization, how you can share and collaborate. But then also, if you wanted to start engaging the public and getting them to contribute and added information, you can also use Hub for that. So it's a great community engagement or multiple community engagement platform. Now, dashboards. I'm hoping that almost everybody in the room is experienced, or at least using, an ArcGIS dashboard. I remember the first time I deployed a dashboard, and I was blown away. We had a Category 1 cyclone spin up in 24 hours from a Category 1 to a Category 5 just off the coast of Australia, and it crossed over and obliterated a large component of our electric network. And I ran the incident response team at the time, and we had tools in place to manage those events, but the way that we had actually configured to respond to those events was all the mobility devices, they were Panasonic ToughPads at the time, had to be brought back into the office, plugged into the LAN cable, and downloaded the latest version of the maps, so then we could go out and do damage assessment. The problem we had at that point in time was that, well, all the crews could not get access to the depot. There was no way to actually come back and download and get the latest maps and apps. We were not using Esri at the time as our GIS provider 10 years ago at that power company. So someone made a suggestion that, have I ever heard of this technology called Servo 123 and dashboards, which I hadn't. And we spun up some Servo 123 forms on the fly. So we were literally putting the wings on the airplane. The storm had hit the coast. Everything was out. We were in darkness in most of the state. And then we were configuring dashboards. And like magic, as people were going out with Servo 123, no training, we just dispatched Servo 123 out to people's phones, gave them no training and said, just start doing damage assessments. As they're going around capturing the data and coming back, as soon as they got connectivity, we're getting dots on this map, we're getting counts. We could see all of a sudden poles down, wires down, dangerous event, road flooded, road closed. We had better visualization and access to information by deploying this solution in one day than we had after deploying our existing mobility platforms with integrations through our IT department from the last 10 years. And all of a sudden, it was like this light bulb moment that, oh my goodness, it is this easy. Like, this technology just works together. The ability to have information come back and be able to be visualized and viewed so you can make better decisions was just absolutely mind-blowing to me. We tried to then deploy it back to our IT department, and they didn't trust it. They didn't think it was possible that you could actually just have this happening in real time, that you could be capturing damage assessments, you're getting dashboard updates in real time. They're like, how does this work? It doesn't make any sense. What is this feature service stuff you're talking about? And it really changed the way that we all of a sudden started managing our data sets. Safe to say that that same power company was at the UC 2 years ago as the largest deployment of the utility network on Esri. So they have completely flipped and become one of the largest Esri shops in the Southern Hemisphere. So it's a great story, but it was actually, for me, it was the dashboards. I was the one building the dashboards. As I said, I've got no experience with code. I was just dragging and dropping, creating widgets, and I was creating the dashboards that we were using to communicate with both our media, our executives, our field crews out, and that were going out to do the work. And that was one of the best restoration responses we've ever had. We saved over $1 million a day during that response by using Servo 123 integrated to dashboards, and it was a phenomenal story. So these dashboards, they're dynamic visual reporting tools, right, if you're familiar with them. You've seen a lot of them be presented today, but they really help you understand trends in your data, the monitoring of the information sets. They're really starting to connect into a lot of these real-time data sources as well to help you manage a lot of your performance. And now you can see dashboards on your mobile devices as well. So it's not just the crew going out to collect the data. They can actually start seeing the results of what they've been collecting as well, coming back to them in real time. And we will continue to make improvements, such as the enhancements to a lot of this accessibility on these dashboards. In the area of smart mapping, we've been doing a lot of work of recent with Microsoft for the last few years to help enable the use of ArcGIS directly within Microsoft 365 apps. So any of your Office apps like Excel, Power BI, SharePoint, Teams, they're all now native integrated in with Esri. So a lot of organizations are not familiar with this and not taking advantage of this capability, but if you are using Esri, you have access to all this capability for Microsoft 365 as well. So please, I do encourage you, if you haven't been using it or you haven't looked at that, I do encourage you to take advantage of it. It does surprise me how many organizations were just not aware that we have actually integrated and deployed a lot of these capabilities with Microsoft. I want to change gears and start looking at ArcGIS now as a really comprehensive spatial analytics system. So what I mean by this is that it has these powerful capabilities, which is like thousands of tools and functions for manipulating a lot of your spatial data. So these tools are really empowering analysts and data scientists within your organization, and they're a comprehensive analytics system, which is really bringing, I guess, your science now into action. A lot of organizations have actually, recruited data scientists within their organization, and they're leveraging the power of GIS to help them solve a lot of their business challenges. So within this space of data science, we've added a lot of tools and methods that continue to advance the spatial science capabilities. So some of these improvements are around hotspot analysis and last mile deliveries. A lot of our robust statistical change detection methods have also been improved. We've also been working on now integrating AI in with our spatial data sets as well. So this is a term that you may have heard. We call it GeoAI. And this is really helping us to increase the understanding and solve a lot of these spatial problems. Our work is also cloud native, bringing in big data analytics, which means that you now can perform the analysis where the data is hosted in the cloud using our geoanalytics engines. So all of these tools are really helping our users generate a lot of the insights that you need to support your decision making. And I'm excited to have here to show how we can use analysis in ArcGIS for making data-driven decisions. Please welcome Donatas.
Thank you. Thank you. One of the things associated with climate change is heat waves. And in recent years, we have some heat during summer months, quite much. So what I'm going to do is I'm going to investigate into the resilience against the heat waves in Vilnius city. So what is this resilience? It's a more complex phenomena than just heat or temperature. There is a huge difference between a heat wave in a desert and a heat wave in Vilnius city. And the difference is not temperature, it's the population. So the more population we have, the more impact we have from the same degree in the heat. So I will start with the initial data, which is I got it from the Living Atlas. And here we have surface temperatures in Vilnius city for summer months. We have the lack of tree canopy in the city, as the trees are actually providing the shadows, which help to reduce the temperature. And we also have demographics from the official census data. Now, I'm going to combine this into one single number for each block in the city. So to do that, I can aggregate the data by the city blocks and get 3 different numbers: surface temperature, lack of tree canopies, and also population density. Now, all these 3 phenomena are both different, have different dimensions, and also some of them are physical and one is demographical. So how could I combine them into one single number? To do that, I have one tool which will do all the required steps: pre-processing, combining, and post-processing to get an index value. So how an index value would look like. Here I have it, the results. By the way, I can run the same tool multiple times and use different input parameters, maybe combine them differently. For example, if I have 2 results, I may even compare them by using our usual swipe, as you can see here. And if I choose one of these results, I may use identification to get the pop-up and compare how a specific block looks like when compared with others. When making a decision based on this result, I may simply look for the worst situations in the city. So if I use a range here, I may find the worst locations where you have people living in huge residential buildings. And okay, I need to. People living in huge residential buildings in locations where there are almost no tree canopies. And during summer months, these people are actually suffering a lot. So how it could be interpreted, this result? Simply planting a single tree would make the highest impact in that location. Thank you. Now I am going to another situation. So another phenomena related to climate change is also very heavy rains. So now in ArcGIS Pro we have a simulation which allows us to simulate water falling from above during a very heavy rain. What I can do is I can distribute a certain amount of water in time, in some time spans, and in this case I am pouring 50 millimeters of water in 1 single hour, and usually in such an event most of the water falls during the initial phase of the rain, and you can see graphically that I can see water accumulating on the surface. I can model very different additional parameters, like, for example, infiltration, how this water is going into the surface. And I can use this also not with only with orthophoto imagery, but also with surface areas, surface cover areas. And also, I would be able to see how they impact the existing infrastructure. So, thank you, and back to you, Matt.
Thanks, Donatas. Some of the questions that people are trying to answer can't often come from one type of data set. It is this layering of information together and doing that analysis. I mean, as a simple example, population, trees, and temperature, to try and understand that. But any one of those on their own only give you a little bit of the analysis that you need. And it's only when you overlay these layers and perform this that you start seeing those trends or those patterns. You can apply that same logic almost into every one of your workflows. Think about asset management. Where are the assets that you have? How are they failing? Or what age are they? What condition have they currently got? When is the capital expenditure program going to happen? And all of a sudden you start understanding all these different types of layers in spatial context, because it's not just about replacing assets because they're old. It's often where they're physically located. Where those assets are is actually having an impact on a lot of those maintenance strategies. Moving along, we're looking at integrating AI into ArcGIS. Now, the notion of GeoAI into analytics provides a lot of our ready-to-use tools and models that focus on feature extraction and really performing this predictive analytics and solving spatial problems. So a lot of this is now using the latest machine learning and deep learning algorithms and methods that are available, but when applied to imagery, text, video, tabular data, GeoAI really is starting to help organizations see a lot of these complex patterns and automate a lot of the workflows, and giving you the ability really to change or adapt and extract insights more efficiently. We've also been working on integrating AI into ArcGIS. Think of this as maybe AI infused, or some of the terminology now, AI assisted. Okay? This will be made available within Pro, Online, and Enterprise and other applications as we move forward with a lot of the mapping, analytics, and data management solutions. But right now we're in some of our early beta testing on some of this capability. And the intent really is to improve the user productivity, providing really this valuable ability to get faster insights through intelligent assistance and using some of these AI agents, for lack of better terminology. So overall, we see this as a tool that's going to enhance your experience for the users, not replace GIS specialists, becoming more of an intelligent GIS platform for these organizations. So here we actually have our AI assistant that we're going to be using. So we've given a lot of the technology demonstrations today. Trying to find the right tool for the right job really can be quite complex. We have hundreds of tools now available to you as GIS users, so knowing which geoprocessing tool to use for what application can be quite difficult. So this is where now our AI assistant can start coming in and providing some of these capabilities. So an AI assistant in ArcGIS can really work alongside of you. every step of the way along this process to help you streamline some of these processes. So imagine that we're tasked with assessing the preparedness of a supply chain for a hurricane that's coming in. So begin by asking the assistant, what data sets do you have for storms? So on the left here, we see the responses from the assistant on how, and that it begins to create a plan. We can see the statuses, we can see the updates and the summaries as they occur. The assistant then displays all the results on the right-hand side. So what is cool is that it doesn't matter what you ask, right? You could have asked, who has data for this storm, or is it published layers? The assistant will find the right keywords. So let's explore the USA storm report, and we ask the assistant, using this layer, where do the events occur? Now it's going away, right? And it's grabbing information and creating reports, and it's checking the completeness of this data set as well. So now you can see a table down below here, and it's given back percentages of the completeness of a lot of the columns. Now it's identified that it's got a Latin long automatically. So now it said, I'm creating a map. And because we asked where are these storms, it's decided that a heat map was the best way to do this. So it's automatically grabbed that and brought that in. So can you make me a map of these trends, right? So let's ask the storm, is it increasing over time? Because we asked it over time, it started to bring in, I can't read it, it's too small. I'm too old, my eyes are gone. But the AI assistant is executing the trend analysis now. So what you can see here is that we've got all the hotspot analysis. It determined that it also had states. So it's gone out to the Living Atlas and grabbed all the boundaries for the states and tabulated this data and categorized it into tabular form per state. So it's automatically done this. Next we ask, show me it over time. Show me a map of these trends. Takes all this data, it's time enabled it automatically. It's then created these charts showing the breakdown of states over time. Now, tables are fun, and you can see this as you've got them here, but I want to take this and see it on a map. So what about seeing this now on a map, managing these events over time on a map? Now we want to start looking at some of the information sets here. It's automatically created the graphics that by the type of the queries that are being run. We can see the results starting to appear over time. We can start seeing, well, these are the worst performing states. And now we want to start saying, this is good, I understand, I can see what's happening over time. What about, now it's going through a query. So now we're starting to we want to start understanding if a hurricane was coming in, where is it actually going to impact my supply chain? It now went out and ran a link analysis on our data sets, grabbed the query analysis, and now coming back and using that information set has created, this is where the supply chain will be impacted on where this is going to happen if this hurricane come in and impacted our network. All of this happened by just asking 4 questions to the AI assistant. You didn't have to know what processes to run. You didn't have to go into the back end and do any calculations yourself. It was just figuring out, based upon the questions that you asked, what to run and providing the information back. As it found more spatial data, it was converting it into a map. So you were getting maps, you were getting charts, and you were getting visualizations and analysis built on queries, all because of the data sets that it was going out to find. This sort of capability, we believe, is going to be quite powerful in helping you really accelerate your decision making and bringing together a lot of the processing tools on how GeoAI will be used within your organizations. Do you think this is interesting? Yeah? So when we talk about GeoAI, I'm aware that GeoAI or AI at the moment is the buzzword that a lot of people are using. But it's not new to GIS. Like, AI has been around a long time. We have many, many, many different models already existing within our platform. For years, ArcGIS has included these pre-trained models. These enable you to start extracting, classifying, detecting information immediately within your data, really automating a lot of these large data sets. You can access over 60 pre-trained models already, which are available within our platform, specifically using for working on imagery types and designed for different business models and needs, including the detection for infrastructure, planning, land cover, road delineations, segments, really anything that you want to model and so on. And you can see a list of some of the new ones that we've just released in the last year as well. Now, to take you through some of the latest GeoAI in ArcGIS, please welcome back Dividas.
I'm going to present a few examples of applying deep learning across ArcGIS. So what we're seeing here now is I have a LiDAR data set which is not classified, so it's not much use for us for analysis or feature extraction. And in ArcGIS Pro, we can classify this point cloud. And we have automated classification tools which are integrated into ArcGIS Pro, but we also have a deep learning capability to apply pre-trained deep learning models for classifying point clouds. So after applying these tools, we can go from LiDAR dataset looking like this to something like this, where we can immediately see that different colors are actually showing points that belong to different classes. So for example, we can immediately see buildings, ground, we can see wires, and so on. By using ArcGIS Pro with classified LiDAR point cloud, we can extract features out of it. So some of the examples of feature extraction are power lines, 3D buildings, and we can also calculate and prepare a 3D power line exclusion zone. So now I would like to take you to a 2D map where I have the same data. And right here I have a task. I need to figure out which of these detected buildings are actually built after 2016, since at this point some of the legal regulations regarding power line exclusion zone have changed. So for this task, I will use a high quality Pleiades Neo satellite imagery. It's a 15 centimeter satellite imagery from 2016. And for detecting buildings, I'm going to use a pre-trained deep learning model called TextSam. And this model is especially interesting because it can detect objects based on text prompt. So I have already used this tool. And for my text prompt, I have used rooftops. So let's see the result. So right now you can see these red lines which are showing detected building footprints. And then I can compare these footprints with my LiDAR building footprints. I can easily see which of these buildings are built after 2016. These are these blue polygons that are left on the screen. So as you can see, difficult question can be easily answered only using one pre-trained deep learning model in ArcGIS Pro. Let's move to another example. Here you can see a car moving. This is a video feed from a car. And you see these green rectangles appearing. What are they? These are actually detected issues on the road. So basically, deep learning was applied to this video feed to detect issues on the road, like cracks, blurred lines, and so on. So we have detected these issues. We can use ArcGIS full motion video solution in ArcGIS Pro to actually visualize where the car is going and what the video feed is actually seeing on the map, as you can see right here. But one thing we are missing, we see detected objects in the video feed, but we don't see them on the map, right? So we can also solve this issue using ArcGIS. So what we did, we extracted the frames with detected issues from the video feed, used the GPS coordinates from the car, and actually combine this data to have a feature class to see these points on the road which are actually marking different issues detected on the video feed. And by having this, we have documented issues on the road, and we can also create a report to show executives or some other decision makers. Such a report could look like this. So for example, we have a section, a 102nd kilometer, we have a count of defects, a map, and also a list of different defects with their coordinates and road where they detected. And last example of applying deep learning is another example with deep learning applied to a video feed. So what you're seeing here is one of the busy intersections in Vilnius. And right here you can notice that once a car enters an intersection, it is detected by a deep learning. And once it exits to one of the 4 possible exits, it's also marked by a different color rectangle. So this deep learning this deep learning workflow was applied to a drone video, but it could be just as easily applied to other sources of video, such as traffic cameras overwatching intersections. And in this way, we can actually detect the cars, detect their movement, where they are exiting, but this is just one part of the problem that we're trying to solve here. Another benefit comes from the ability to store this data, analyze and visualize, and this is where ArcGIS can provide us with all the necessary tools and capabilities. So this is a ArcGIS Experience Builder app where I have a time-aware web map with the same intersection, and I have aggregated traffic flow data into 30 seconds intervals, where I can easily visualize where cars have been going, right? Where are they exiting which exits are, like you have a lot of cars are exiting, right? And I also can see some charts with the aggregated combined traffic by type, and I also can bring my video feed right here. So by using deep learning and applying it to a traffic monitoring, we can easily create a citywide traffic monitoring system. Thank you.
Thanks, Davidas. I think some great examples there on the applications of the AI. Now, if you think about it, a lot of the value comes here where you can automate a lot of the manual processes at a scale that it just wouldn't be feasible to do if you're sitting at a desktop anymore. You're talking, a lot of this imagery data is petabytes of data that you need to process and make decisions on. What we're doing now is automating a lot of those workflows. So now you can just use our object detection, change detection, these deep learning and AI models to get that information into a dashboard or into something that is effectively consumable that you can make decisions on. Another great example we often see is the before and afters of major events. So how many buildings were damaged, or what roads are flooded, or what trees are down, or what was the impact in that area. It's a really great way of visualizing and automating a lot of that change detection after major events. We're talking about big data, we're talking about imagery data, we're talking about consumption about a lot of this. Now, we're doing a lot of work at the moment on the spatial analysis for big data as well. So what we're doing is leveraging our Spark environments. So for spatial analysis of big data, this means that you can analyze big data in your own cloud native or on-premise environments using our GeoAnalytics engine. We saw a little bit of the example of the GeoAnalytics engine as we're looking at that drone earlier as it was flying into those exclusion zones, which provides these powerful spatial tools and an extensive set of our spatial functions that really does make your organization's big data workflows more spatially aware. And that's really the ultimate outcome of what we're trying to do. Bringing in this analytics to your data sets helps you and your organizations really leverage their existing cloud computing investments and integrate spatial operations into these data sets, bringing that science into the work that you do. We talk about integrating big data sets, but I think a lot of this is also about integrating your real-time data sets. I spoke earlier about the importance of connecting what you see in the control room or in your operations view, whether it's dispatching work or managing situation awareness, and how that's being transferred and communicating to the rest of your organizations. So we're continuing to enhance these real-time visualizations analytics, removing that information latency of how you can get this data across your organization. And this is really bringing in the IoT and real-time information sets together. So in ArcGIS, this capability is represented in GeoEvent Server and Velocity. And we've made a number of enhancements in each of these in recent years. So in GeoEvent, the focus really has been to continue on the usability and performance. For Velocity, though, our SaaS solution, we continue to work on data visualization and big data analysis, along with a lot of the usability improvements as well. So this technology really does support your operations and improving your real-time decision-making within your organization. We saw a little bit of an example of the link analysis in the AI assistant there, how it was going out and trying to understand the supply chains. But last year, we added support for a technology called link analysis. So this enables organizations and analysts to integrate a lot of their diverse sources of data together in a new data model called knowledge graphs. So if you're not familiar with knowledge graphs, these are a way to integrate and gain many-to-many relationships, which are hidden across silo business systems, including those which are often buried in text documents and reports. Now, if you're familiar with working in any sort of database, whether it's an SAP database or an in-house database, a lot of your asset management programs or the way that they're configured is a parent-child relationship. All right? So you have to drill down through a hierarchical tree. What graph engines analysis do, it enables you to actually connect and go across different data sets. So you can start trying to understand supply chains of your assets in relationship to the financials of those assets or failure analysis of those assets. So these are not tracked in your traditional hierarchical databases, but they are related through graph engines. So this is relatively new to ArcGIS, but we're already really seeing some breakthrough applications on how it can be applied within organizations. Things like social networking understanding, crime analysis, supply chain, as I said, risk assessments, and that's really just to name a few. But we are seeing some really good applications of this technology. And soon we will make these knowledge graphs more accessible. They'll be available on the web, and to continue enriching a lot of our graph engine analytics and capabilities. So to show you how you can use the ArcGIS knowledge through investigative analysis with ArcGIS knowledge, please welcome to the stage Inessa.
I will shortly show you the power of ArcGIS knowledge and also graph analytics, also keeping in mind the benefits of geospatial view and of data. We have already injected data from famous offshore leaks database, and I am playing in an inspector and analyst, and keep in mind the story what I'm showing, and also our involved persons are the fictional. Okay, now we will move to the story. I have a task to find links and connections between three potential suspects. We have outsourced the data that they are working together, and there is the tax fraud possible, and also, mostly likely, the money is transferred to Russia. You can see already in link chart I have already two suspects, and I can easily add the third suspect. I found it, adding to the link chart. And now we see all three suspects. And the main suspect for me is the Maxim. And I want to see what we already have, what kind of data we already have about him. Okay, I will change the layout. From this, we will see that we don't have direct connections with other suspects. But that's why I will try to find the paths between them. From this, I see that Maxim are shareholder to some offshore companies, what is linked also to Ivan. But we see that I don't have in data connection between Igor Roland. That's why I will expand what we see about Igor Roland. And maybe there is other potential suspects that we can link together and maybe link together in geospatially. That's why I will again change the layout to geographic. Sorry. Now we can see all region where all are taken. And I already done geoprocessing and analyze that there are some neighbors or people potentially living close near. And from that analysis, we see that there is 2 suspects what is living really close. And I can use this clue for my future investigation. And for future investigation, I can also use already geoprocessed analyzed tools what we already have, like walking distance, if it's reaching Margarita. Also, we can use also other spatial data to better understand what we see in the view. Like here, there's the OpenStreetMap data with all the information that we have, and also we can see imagery to better see the location where is Anna. After the investigation, we can also make the reports where we can include our link charts, what we have, also the maps and analysis, also comments, and if we need other features to add, we can also add these. This is all from me, and yeah, if you want to get more know what is ArcGIS knowledge, tomorrow we have also the technical session. This is from me. Oh, thank you.
Thanks, Vanessa. When I saw that for the first time when we were doing the rehearsals, I hadn't seen some of those workflows at Inessa. So, I mean, she was effectively doing the, was it offshore? What was the word? Offshore database, and doing auditing and tracking between these entities. Now, she changed the names, so I hope none of those names were anyone in the audience. They were fake names. But it was like tracking people through and how are they related without being directly related. And ironically, the way that they end up being closely related was through location. But even within your workflows, within your organization, as I was talking about before, that many-to-many relationship is very important for you to be able to track. So an example that I was thinking of when I was watching that was, I was working at a substation and a CT exploded. It's a porcelain device, and it exploded into a lot of pieces, and a piece of it went through the side of the building and actually went inside the building. That's how damaging these things are when they explode. And the executives at the time said, I want to know the condition of every one of those types of CTs that we have and show me where they are. And the issue that we had was we had an asset management database that was disconnected to our stores and supply chain. So we had stock codes, but they weren't really connected to the condition of these assets. So first thing we had to do was go find out where they all were. That was a very expensive exercise. Then we had to determine, well, who supplied them and when were they supplied? That was almost impossible to do with the data sets we had. So this exercise, which should have just been running one of these analyses and getting that information in a matter of seconds, ended up costing us in the order of about $10 million to go and inspect every single one of those assets so we could prove that it wasn't going to explode and go through the side of a building. So connecting your supply chain to your stores, to your logistics, to your asset managers, to your failure database, to your financials, all of that can be done through this technology, right? So it's that many-to-many relationships and then seeing it spatially to see how it was impacted on your network. So a great example, thank you. I want to move now into some of the technologies we did demonstrate in the first session around ArcGIS being a complete 3D GIS. So this is really a system now for managing and integrating all types of 3D content, creating that platform of really, as we showed earlier, your living digital twins. And the 3D capabilities that we're talking about are advancing right across the entire ArcGIS platform. So this is coming in from 3D analytics to your analysis of immersive experiences. There's now hundreds of tools that we have available that you can extract and use within your organizations. So you can take the 3D visualization tools. We've been working on many things to optimize a lot of the realistic visualizations. We've been integrating more into a lot more data formats as well as we consume these 3D data types. So connecting your ArcGIS also into some of the immersive technologies to create those better visualizations and experiences as you start moving into those what-if scenarios is also important. So once again, connecting maybe into those SDKs of Unity and Unreal. This is really starting to open up a lot of the new capabilities that our users want to leverage within our technology stack. Moving into ArcGIS now as a comprehensive imagery management system. Now, we did talk about this. This is one of the fastest growing areas of interest within our GIS community. Imagery and remote sensing is really the foundational data set now as organizations are trying to move into this 3D world or these digital twins. So inside ArcGIS, there's now hundreds of image analysis and visualization tools that integrate and manage all the different types of imagery that you have. So when we look at some of the capabilities, we start with reality mapping. So this is really where we see the ability for us to capture, manage, and maintain a lot of our digital elevation models, digital terrain models, and things like that. In terms of content or data management, we now provide over 120 different imagery layers which are available to you from multiple authoritative data sources. These include things like the Landsat information, the Sentinel data, and we make it available through the Living Atlas, which, as I spoke about earlier, is already available to you. In the analysis space, ArcGIS includes a large set of tools for helping you do things like we showed earlier, change detection, raster analysis, and things like that. And you can combine a lot of this imagery analysis with your AI or GeoAI, really starting to streamline and automate some of these processes, integrating in with some of those pre-trained models that we saw. In the visualization space, this is really giving your stakeholders the ability to turn imagery as an information set. Too often we see imagery stored underneath somebody's desk. It's in hard drives and hard drives and hard drives. We need to democratize that. We need to get it out from under people's desks. We need to treat imagery as an information set and start sharing it across our organization. It is a really powerful foundational component of moving your organization forward. Treat imagery as an information set that needs to be captured, managed, and maintained over a life cycle, and that'll really start to help you integrate and move a lot of these workflows forward within your organization. And there's a lot of tools now that we have available to help you do that in the visualization space. To talk through how we can empower your analysis with satellite imagery in ArcGIS, please welcome to the stage, Žygimantas.
Thank you, Matt. As I always like to say, let us see with imagery, right? So, okay, so normally to visualize satellite data in ArcGIS Pro, for example, first you may need to register to an online data hub, select, filter, download the data, and only then you can visualize it. Well, I'm here to remind you that you already have lots of different satellite imagery available in your ArcGIS Pro, which you can easily find, add to your project using the Esri Living Atlas library. You can add imagery for a quick visual analysis, but if you want to, you can also clip and export this data for more complex workflows. Now, unfortunately, free satellite data may sometimes be lacking in spatial or temporal resolution. In such cases, commercial satellite data providers like Planet, who offer medium resolution imagery with daily revisit times and global coverage, can really help accomplish our tasks. So, for example, Planet have an ArcGIS Pro add-in that easily integrates their extensive archives into one place where you can search for images and, if you wish, download and add them to your project right in one place. Now, to better understand the differences of what you can expect between free and commercial satellite data, let's do a quick comparison. So right here, I have a 10-meter resolution image of the Sentinel-2 satellite, and I'm zoomed in to an extent of 1 to 20,000. Now, visually, the smallest objects you can probably identify are buildings, perhaps roads and rivers, right? But let's see what happens when I add a commercial image to my map. So suddenly, not only I can identify buildings, I can even identify cars. I can tell what color they are. I can also identify road signs, electrical poles, and similar sized objects. Now, this particular image right here was taken by the satellite Pleiades NEA, which belongs to Airbus. And after pan sharpening, this satellite offers a resolution of 30 centimeters. But if that is not enough, then Airbus also provides a product of the same satellite, which has an increased resolution of up to even 15 centimeters, which you can see right here. Now, I also have some aerial imagery so that we can compare it with the 15 centimeter Pleiades NEA product. So the aerial imagery is on the left and the Pleiades NEA is on the right. And you can probably tell that it is much more difficult to detect road signs or identify electrical poles in the image on the left, which is the aerial photography, which has a resolution of 25 centimeters. Now, you can use imagery in a lot of different domains, such as agriculture, defense and intelligence, and many more. But today, let's focus on detecting land cover or land use changes. So, to find and quantify those changes, I have two orthophotos done 10 years apart in 2010 and 2020. I am a land cover. My job is to detect and find and quantify those changes that happen in this area in Lithuania near the city of Tauragė. So I have used a pre-trained Esri deep learning model to classify both of my images into land cover types. And after doing that, I've simply calculated categorical differences or computed a change raster, which you can see right here. If we zoom in to an area of interest, like for example, right here in this location, if we swipe the two images, you will find that during those 10 years, a pond was extended in this location. And this pond extension is actually represented in the change raster. If I click it, it will show me that the land cover changed from low vegetation to water. And in another use case, we can see that the change raster indicates that land cover changed from low vegetation to structures. Well, if we swipe the two images, we will see that that in fact has happened at this location. Now, although optical imagery is easy to process usually and interpret, it may not always be possible to detect short-term or long-term changes because of atmospheric effects such as clouds. So this scenery that you see right here is actually quite common in our latitudes, where small cumulus clouds cover large territories, and not only the clouds themselves, but the shadows that they provide usually make the image mostly unusable. So here I will introduce you to a different type of imagery, which is called SAR imagery or radar data. And if we compare these two images that were done on the same day, you will notice that there are no structures similar to clouds in the radar data, since they have no effect on it. And if we look at this particular location, you will see that there is a lake here, which you can identify in the radar data, but the same lake is hidden in the optical image. So, by using the Sentinel-1 radar data, I can identify changes visually using an RGB composite, where different bands represent different images taken at different moments in time. But I am also able to quantify those changes. So for this example, I have taken two Sentinel-1 images done 5 years apart. And after some pre-processing and after I've used some math tools, I was able to identify and quantify meaningful differences that have happened during those 5 years. And if we zoom into an area of interest, you will see that during those 5 years, in the radar data, a white blob has appeared in this location. Well, if we look at the world imagery, which is available from Esri, and we swipe these two optical images, you will find that during those 5 years, a construction site has appeared in this location. Now, Sentinel-1 is free, but it's not daily nor high resolution. So commercial radar data may be a better alternative. So here I am zoomed into the port of Rotterdam. And again, what you see here is a Sentinel-1 image, and it is quite hard to identify certain objects such as ships or anything else. But if I turn on the commercial radar data, now suddenly you are able not to only identify ships, but also shipping containers that are at the port of Rotterdam. So what I've just shown you are only glimpses of what you can do with imagery in just the ArcGIS Pro. Overall, the entire ArcGIS ecosystem offers extensive support for different, even niche sensors or workflows used for in different domains that I didn't show today, such as climatology, geology, and many more. So thank you for listening, and back to you, Matt.
Thank you. You can tell that he's quite passionate about imagery, can't you? When I get in a room with the imagery guys, I quickly realize I'm out of my depth on technical knowledge. I mean, they go so quickly, so deep down into a language that I struggle to understand. But even when I watched that for the first time, I was even amazed about how many data sets are now available that you can consume through our imagery service. And it's really about finding the right level of fidelity or the right imagery service to meet your business requirements. And sometimes you do need 15 centimeter, 3 centimeter accuracies. Other time, 30 centimeter accuracy will be enough. And those data sets are readily available. And it's just about understanding what is right or fit for purpose for the workflows you need to do. But there is definitely a lot of content that you can consume. We're going to move along now and just focus in on a couple of the some of the ArcGIS products that we have in our platform. We mentioned a lot of the capabilities with GeoBIM, but we just want to call out how important this is in the relationship and how ArcGIS now is integrating AEC content and workflows. We are seeing a huge development in our architecture, engineering, and construction firms as they develop and start spawning large GIS practices within their organizations. And they're starting to deliver a lot of these project delivery workflows, integrating ArcGIS and BIM, streamlining that project delivery workflow, as I said, connecting Autodesk Construction Cloud to Esri, and bringing in and linking all of these features and data sets, which is creating a new value proposition for the users. This model that they're deploying is starting to filter down and be delivered into a lot of the other industries that they serve. So the AEC companies are the ones that are effectively building the new infrastructure of the future. They're the ones doing the big bridge projects, the new infrastructure transmission projects, the new railways, the new infrastructure that's required to meet the demands of the future. And so these organizations are really starting to accelerate the capabilities of integrating our technology in this space. So I do encourage you to keep a pace with this. If you haven't seen some of the webinars that are happening in the AEC industry and what these guys are doing, it really is transformational and pushing the boundaries of what the technology can do. Also, I want to talk about how we can create and manage geospatial data. I spoke about earlier about the system of record, or that transactional data sets that we have. So this is really integrating our data sets now and how we can start leveraging the power of being that system or single source of truth and integrating master data management within your organization. So we mentioned about the network information model earlier, using the utility network as an example. But this is really starting to integrate now into a lot of other workflows. So as I was talking about before, streamlining those workflows, trusting the people out in the field more, that when they make a design change or an edit out in the field, you want that to come straight back into your source systems. So we're moving away in a lot of organizations now from saying, we're going to allow you to capture the data and information in the field, but then we're going to follow our existing processes, and it has to go through 3 more handoffs through QA, QC before we push it to the top or publish it, because that's the way we've always done it. The business rules and the network logic of these new data management solutions are inherent in the data model, which means, as I said, it's already built in at the edge. So we're really starting to push forward with a lot of our ArcGIS web editing capabilities. So this is data editing, data maintenance, and data capture, which has always been core to our GIS. But now we're moving it into those other workflows, more at the edge, more at the mobile devices. So as part of this effort, we're introducing a new user type extension. So ArcGIS Advanced Editing. So this user type will streamline the licensing. It's going to replace the existing utility network, trace network, parcel fabric, user type extensions. It's also going to provide access to the additional advanced data editing and geodatabase capabilities. So this is pretty important if you've been working in this space or you're using those user types. So the ArcGIS Web Editor, right, just to explain it a bit more, it is a focused editing app for simple and advanced specific editing workflows. So think of it that you're now empowering people to do web editing and bring that back into your source system. Okay, it doesn't have to be done hard on the desktop anymore. So GIS professionals now can work in a browser, which is supplementing their desktop editing. And it really is starting to improve, these three things. It's going to enforce your data quality. So that'll happen at the point of capture, as I was talking about earlier. It's going to auto-populate your data values, so you can take all of your information sets out to your web editing solution to be able to be edited with all your business rules. And it's going to enable the data owners to be more self-sufficient. Okay, so this is coming soon. There'll be more of this coming out in the release at UC in July. But this is some of the new capabilities that's coming with ArcGIS web editing. Right, I spoke about my little workflow with Survey 123 earlier and the power that it had during managing that response. But there's a number of tools that Esri has in its mobility stack. So there is Survey 123, which is effectively our smart forms solution. We have Quick Capture, which is really rapid assessment to capture data sets. So imagine you're doing an inspection, you're in a car driving in the street, and you're just trying to track potholes. You could be just capturing pothole, streetlight, sign, and you're rapidly collecting data sets. It's geotagging those. It can associate it to the nearest asset that you have in your database, but you are doing rapid data capture within those tool sets. And then we have our flagship mobility device, which is Field Maps, which really takes all of your network and all of your information sets to the field to allow you to do a lot of those workflows. So ArcGIS supports all of your enterprise field operations and mobile data collections with these three tools. The key thing to note, though, and remember, that these applications are really about connecting your field with the rest of your enterprise. So it's synchronizing the office with the field and providing that location awareness for people in the field. And that's really what this is all about. So to take you through some of our latest innovations in field mapping and data collection, please welcome back Raminta.
Okay. So let's imagine that we could create surveys in a couple of minutes. Now we can do that with the new Smart Assistant capabilities in Survey 123 Web Designer. Let's ask our assistant to create a survey to collect information about why people love GIS. I am really eager to know why our users love GIS. Survey 123 uses large language model to create survey drafts for you using a human-like conversations. So let's take him a little bit of time. Oh, he's already done. And you can see it created a nice questionnaire with some options, the level of the expertise, how often do people use that. And I think this is pretty good. I have multiple options here. I have open-ended questions, but I would like to add an additional question, a map question about our user's hometown. So as you can see, I can go through multiple iterations with my assistant and ask him to reorder fields, add additional ones, remove the ones that I feel are not needed, remove, add options, and so on and so on. And as you can see, it inserted a map question right here. So I think this looks pretty great, and I want to generate this draft. So what it does now, it simply takes each of the question and assigns a specific field type that we need for those questions. So let's hope he is on his duty. Yeah, and as you can see, it attaches appropriate field types here, and if I scroll, I can see all this in my survey draft. I even have my map question, which is even set as required. So I'm almost satisfied. I would like to have the survey in multiple languages. So as you know, you can translate your surveys, and let's add just one language to save our time here, since lunch is approaching. And I could do this by hand, I know Lithuanian, but if I add multiple languages, it's a hard task for me, so I can ask my survey assistant to translate it. So this uses machine translations to automatically translate your surveys into any desired language that you want. So this might take a minute, so I would like to just emphasize that, machine translations, they are improving every day, but you still need to, double check that to make sure that everything is okay. But it does save time, and while this is still in beta, and you can see it already translated, I can review this in Lithuanian. I do encourage you to try it today. And now I would like to move on to my iPad, if my colleagues there could switch me up. Okay, so now let's imagine that we are researchers or simply nature lovers. We're walking around the forest, looking up the trees, trying to find some birds, and we're definitely not looking down at our phones until I get this notification that says that I might see a boreal owl somewhere. This is geofences informing me that based on earlier sightings, I might see this beautiful bird snoozing somewhere in its nest. So lucky me, I do notice somewhere, and I want to report it. As I open the form, I get this nice information about how to use this form, even hyperlinks, to check some additional information and how to start. So as I add a point here, I get additional questions, and as you can see, some of those are pre-filled already, and I can see that I'm in a protected area here, and I get this note that says what species I might find here. So let's say I'm not pretty sure that I did see a boreal owl, so I can check my suspicions not going into any other application, website, or checking an encyclopedia here. I will simply select a species, and once I select it, I will get this beautiful drawing of boreal owl, and I can even listen to its sounds. Well, if someone were asleep, I hope I woke you up. So now I'm pretty sure that this is really a boreal owl, so I can finish this form, submit other information, and submit it. Now let's move back to my laptop, so I will show you how this was configured. So now you see a field maps designer where you can now add info cards for your users to help them guide them through your form. And this supports text formatting, hyperlinks, dynamic questions that people answered before, or even arcade, as you have seen in the demonstration from my iPad. We can also help users, to simplify their work by calculating some information for them, like we had with the population, the protected area that we are in. So we're using arcade for that and a simple expression to get the area that we're in. Additionally, we can guide our users through conditional logic and visibility rules. Let's say this group of questions are only shown when the species is selected. And as you have seen, all this data acts as a geofence for other users so that they get this nice notification that they are near a bird sighting area within 100 meters. And it is dynamic and showing the species that they might encounter. So as we integrate ArcGIS into more and more of our workflows, it's becoming crucial to create an intuitive and easy to use mobile experiences for our field workers. And I think field maps is just the way to do it. Thank you.
Fantastic, Raminta. I mean, it never ceases to amaze me how fast our mobile technology grows. I mean, from where it was just a few years ago, it really is now a complete enterprise field operations system. We've seen a lot of the technology today as we worked our way around some of our more focused products, such as Urban. And what I want to talk about now is how we're taking GIS indoors. Now, Phil touched on a couple of great examples in the first session, but more and more now we're starting to see how GIS is going indoors. We're starting to see the ability to follow that blue dot. And it's not just wayfinding, it's actually integrating all of your asset management workflows, starting to figure out how do we do space management, asset management, facilities management, understand everything in spatial context while still bringing it indoors. So I want to continue by bringing onto the stage here to manage facilities and assets with ArcGIS indoor system. Please welcome Alyssa.
Hi. Hi, my name is Alyssa, and I will talk about how you can take GIS indoors. Imagine everything that you can do with a powerful outdoor GIS. Now, let's take a step inside. With Esri's indoors GIS, you can deliver comprehensive solutions for indoors mapping, asset and space management, analysis, and more. But where to begin? Well, ArcGIS indoors GIS can be created using building data from CAD, BIM, and other data sources. And from that, ArcGIS Pro provides those necessary tools. Now, using floor plan editor web application, organizations can keep their existing floor plans up to date and create new ones from scratch. I will demonstrate for the second floor. I have already started my drawings. So one way is that organization can add their existing like floor plan with floor plan photo, and using provided tools like so, draw new areas. I will quickly draw one. This is one example, and the second one, if you are already familiar with place, you can free-handed draw new areas using sketch tools. When floor plan map is ready to be used, organizations can create apps. For example, using lots of ArcGIS applications, for example, ArcGIS Indoors Viewer. And as you see, this application provides users with necessary information about directions and so on, but 3D gives that extra view of provided paths, so it is more easier to find paths in the building. And if emergency, of course, with power of indoors positioning or IPS, organization can assess the situation better and get to the key location faster. Now, when the hybrid workspace has quickly become new normal, indoors GIS supports organizations, their facility employees and visitors to find necessary room. I can see which rooms today are available for my necessary time. I can look also what kind of assets in the room will be, and simply book my room. I can also view the schedule for this room ahead and make a reservation. Another thing, when employees or visitors find some kind of issues, they can quickly inform building manager for that by simply reporting technical issue using smart forms. For example, this survey 123, I just need to answer some questions regarding my technical issue. Also can take a photo and submit my report. And as mentioned before, ArcGIS dashboards provide that necessary overview for building manager to keep track on facility and asset health and analyzing booking information from the rooms. It is possible to optimize cleaning schedules for rooms by viewing how often and which spaces is being used, and also keep in touch with the information of reported issues, their location, status, and more, and also keep track on already working assets and see their health. So all in all, combining ArcGIS indoors with other applications like Survey 123, dashboards, and so on, organizations can really create comprehensive facility maintenance solutions that meet their everyday work. These were only some of examples how you can bring GIS indoors. So thank you.
Thanks, Alyssa. Fantastic. What we're seeing here is now the integration of indoors, not just as a separate solution that you deploy, but really now an integrated enterprise solution that connects in with things like operational dashboards, Survey 123. It's now connecting in with your asset management databases as well, creating that true facilities management, opening up the world of GIS to a lot of other lines of business within your organizations. One thing I do want to touch on before we break is this notion of ArcGIS implementation resources that are available to you. Now, we've been working for a good bit of time now to develop what's been called as the ArcGIS well-architected framework. So if you're not familiar with this, there's really four main components. There's an overview component, there's system patterns, there's architecture practices, and architecture library. Now, we used to have the best practice guide that was available, but this is really to replace that, and there's a number of resources that are available. There's a website there, architecture.arcgis.com. If you haven't been there, I do suggest you go. It really will help you work with your IT departments on how the best practices to deploy a modern enterprise GIS solution in your organization is. As I was talking about before, deploying it the way you've always done it is different to how you're going to be deploying it moving forward. The GIS of old, of just being a mapping system, is not the same. It used to be maybe 5 nines of availability. A lot of people now are requiring 9 nines of availability. It cannot go down. It's now a mission-critical system within your organization. If the GIS stopped working, you've got thousands of people out in the field that are unable to do their work. This framework, this well-architected framework, will help you understand how best to deploy it, how it is meant to be integrated, and how we can support it throughout those different workflows. It's all the documentation for designing, deploying, and operating your ArcGIS as an enterprise IT system. So I can't stress enough, if you're not familiar with this framework, do go and spend some time there. There's even examples on how to integrate with some of our best asset management partners like SAP. That's all integrated in there as well, and some great examples on how to do that. What's next for ArcGIS? So looking at our roadmap and our strategic roadmap ahead, now you're probably familiar, but we do have our big user conference coming up in July, mid-July. There'll be a lot of announcements on our Q2 releases and what's happening. But we will continue to have these incremental releases of our technology on the various software products to support your work. We will also continue to innovate in all of the fundamental research areas that we spoke about today that are fundamental to what ArcGIS is. And we're committed really to focusing on improving the quality and performance. We know that the technology needs to be stable, secure, reliable, and highly performant. So that is at our core what we are working on to deliver for our customers. And we are releasing a lot of new technology, and we appreciate that sometimes it's difficult to keep pace with what we're releasing, but we are working really hard to make sure that everything is integrating and working well. We touched on it at the beginning, but we have a very large partner network. It's an ecosystem of solution providers, content providers, hardware providers, implementers that are available that you can work with within. And we have quite a number of them here today supporting this event. So please, during the break, spend some time, go talk to these partners, find out what they're doing. A lot of these guys are there to support you. They've created solutions to solve your specific workflows within your organization, effectively designing ways that you can do what you need to do easier, faster, without having to have maybe so many button clicks and streamline a lot of those workflows. So if it's feeling like it's a little bit heavy or you're not familiar, we'll probably have a partner that has optimized this process for you. And there's over 3,000 of them in our ecosystem that you can work with. A lot of us are also working on professional development ourselves. The GIS community as itself, as we try and keep pace, We have a whole new suite of MOOCs and learning programs and web courses, instructor-led courses that are available. There will be a new one that's coming out. I've just got a preview of it on the well-architected framework. It is a 4-hour course. I'll be reviewing that in the next couple of days, but that'll be made available to you also on how to implement the best practices for that well-architected framework. But there is a lot of tutorials and learning development plans available on our technology. So if you're not familiar with that, please have a look at it. Work with your managers, work with your supervisors, make sure it's in your development plans that they're supporting you and understand that these really are the skills that are required for you to do your job both today and moving forward into the future. So we're coming to an end. It is lunchtime. We're at just a little over. But first of all, I want to thank all the great presentations today before we head off. They all came together brilliantly, so thank you for all the hard work getting it all put together. I know it can be quite stressful getting ready for these big events. But as we spoke about earlier today, the technology plays a major role, but you as individuals, I think, have just as much an important role to play as we start trying to solve some of these challenges that we're facing. You're really part of a cog in a much larger wheel, right? And it's about creating and influencing the future, not just of our nation, but really of our planet, right? You and the work that you do is essential. It's about creating that sustainable future. We need to think bigger, and we need to start thinking about, well, what does the future look like, and what does the world look like that we would like to create, and what do we want to see? So with that, I'm going to hand it back over to finish up. Javila, would you want to finish us off? Thank you very much. Appreciate it.
Thank you, Matt. Thank you so